Hello, everyone. So, welcome to this talk. So, my name is Sam Bessalah. I'm a software engineer. I work as a freelance, doing distributed systems, working with big data, huge, small data. So, yes. So, I'm going to talk about building high-performance servers. But that was the first title of the talk. So, in the end, I came up with actually talking about building high-performance RPC on the JVM using Finagle. So every time I talk about RPC today, people tend to, especially developers, they tend to look at me with big eyes. I mean, what are you doing RPC? We have REST, we have JSON, we even have XML. I mean, why you want to do things like Corba? Why do you want to do things like RMI? Why do you want to go back to this kind of stuff? That's, yes, I mean, when you talk about RPC to people, that's the first thing that comes into mind, which is good old middleware RPC, but that's not the kind of RPC that I'm talking about. So why would you want to use RPC today? I mean, there are still many cases where we use REST. I mean, I'll bet that's the wrong way to use REST, but that's still most of the people. Many people are still using REST as being an RPC, using JSON as a serialization format, and that's really not the good way to go. You want to use RPC when you have full control over your environment, when you know your clients, because in any distributed systems, clients are always the one who actually bring trouble. When you can control your servers, when you know what you're doing, you know exactly, I'm in private network or in a network that I control, I can say exactly what I'm showing to people, to my client. I can control my servers. I know how my client can behave, because you never know what's going to happen anyway. So in that way, using RPC makes sense. Another way is when you need predictable performance. You want to know exactly at this threshold, I want to have this kind of performance. When you're on the internet, you can't predict that kind of performance because you're on the internet, you don't have control over your network, you don't know exactly what you're doing. It's a bit hard to do RPC when you're on the web. But when you're in an intranet, on internal services, it makes sense to actually use RPC. And one other way to use RPC is when you want to communicate between different clients within different languages, whether you have a server in Java, another one in Scala. I mean, you can call Java and Scala. You want to talk with Python servers. You don't want to use JSON over the wire. You want to talk with PHP servers if you hate yourself that much. But that's really, in that case, well, it makes sense to actually use RPC. And one thing that RPC brings is isolated computation. You can say, okay, this kind of computation, I can isolate it in the network. I know exactly how it's working there. So that way, it's a bit hard to do that with REST. It doesn't matter what framework you're using. But yes, with RPC, you can do that. And when you have things like fan out and fan in distributed systems, I'll come back later about fan out, fan in systems. So the RPC system that I'm going to talk about is Finagle. Finagle is something that came out of Twitter. So it was meant to solve one problem, one huge problem that Twitter had. I think you guys remember what it was what Twitter fail whale, where you could go at Twitter 10 times in a day and still going to a server, to a system that's not working. That was a real pain because they had this monolith in Ruby that was hitting a database behind without not thinking about the architecture. That was a big pain back then. So they came up with a solution that's to use microservices. But you can see Twitter that you have a timeline. That timeline calls multiple systems downstream, yes. That systems meaning that when you're hitting the Twitter API, you're reading a graph, you're using the user service, the follower service, you're using a search service, you're actually finding out your rights. From the API, one call makes multiple calls, and those calls are aggregated between your timeline to come back below with finding in your reads. And if you don't have the proper data store, if you want to call these services one by one, it's a bit troubling. Now, you can think that, yes, but I'm not Twitter. But in many applications, this is actually what you do. You're calling multiple services, and you have to compose them to get a result, which happens more often than we think. And in this case, using RPC is something that you can compose and make sense. So Twitter came up with Finagle. So let's go to Finagle. So Finagle is an asynchronous, non-blocking, protocol agnostic, meaning that I can use JSON, XML, whatever I like, as long as I can support it myself and plug it into Finagle. And it's a full stack platform to build RPC system. The good thing about it is that unlike what you already have in the Java, in the Scala world, things like Akka, Spray, Play, they build on top of actually high performance transport networking system called NATI. This is the fastest, the most used high-performance networking layer on the JVM, which is NATI. I'm not going to dive into NATI, but that you have a lot of things that you use NATI today, whether from Finagle, you have web frameworks. A lot of services today are built from high-frequency tradings to banking to real-time bidding. So NATI is really prevalent, and it's really fast. So they built Finagle as being a way to compose your application on top on a fast, reliable, and high-performance net transporting layer. We'll come back to it later on. And one of the guys actually who started Finagle at Twitter, his name Marius Henriksson, and he came up with this paper that is called your server as a function. Remember, Finagle is written in Scala, and they try to be as much as close to functional programming paradigm as possible. Functional programming comes with drawbacks, but yes, in Finagle, we try to keep those drawbacks a little bit, to have little less consequences in the way you use it in production. So they came up with this paper where they explain exactly how you build a server by composing functions. That's exactly what Finagle brings to you. We see a little bit later, but this is a nice paper to read if you can go there. It explains the philosophy behind Finagle. And Finagle is not just a way to build high-performance servers, but it's also a really production-ready distributed toolbox for distributed systems. It comes with a lot of features. I'm not going to dive into all of them, but you have load balancing, way to handle back pressures, a way to handle failure detection, failover, how to pool your resources, and how to do tracing with a lot of frameworks. So Finagle is not just a library, but it's actually a whole ecosystem of libraries built on top of all the core that is Finagle itself. So it's used by a lot of companies today, and this is just a recent one. That is our latest people who actually advertise that they're using Finagle, but you have a lot more of them. People, either you use Finagle for something when you have to build a proxy or something what to handle asynchronous calling, and then they use something else for the website of the framework of the application. So, like I said, Finagle is actually a set of applications built on top of NATI as a networking transport layer. So what you have is actually a transporting layer here that you have a transport, on top of which you have a dispatcher that dispatches all your requests and all your incoming data to transport them into the layer. You have a pool of connection that handle the concurrency of your connection when they come into Finagle. They also have a way to load balance inside Finagle for your clients when they connect to a Finagle application, and a way to build services. This is actually a set of some of the main functions built into Finagle. And the networking layer is just a NATI, which is built itself on top of Java and I/O. It shares a pool of connections between Finagle and the NATI pool of connection, that what is called the event loop. And with this pool, you have protocol, services, and filters. We come back to this later on. Just to give you an idea, so you have NATI, a pool of connection to handle connections that are shared between Finagle. This is the networking layer. So it used to be that you would see NATI API creeping out into Finagle, but this has changed a little bit, so we still learn on how we can write services with Finagle. So, like I said, Finagle building blocks, when you want to code application, you have three concepts. You have the concept of features, services, and filters. I think everyone is familiar with features here, right? Who knows features? Yes, almost everybody. So features are actually a way, like if you know Akka, you have actors to build application as a way of doing concurrency. Feature is actually a placeholder to do asynchronous computation. So basically you have them in the JVM, in the Java API as well, but the features in Finagle are themselves different from the feature from Scala. This can be a bit confusing at times, but they just what you have as feature, but implemented with feature way One of the advantages that they have is the way they handle context switching, and they tend to be more performant in some cases, especially when you have to compose a lot of features compared to the one you have with Akka feature or even with the Java features, unless you're using, of course, the completable features that you have in the JVM today. And there are also exception and error handling. This is a feature that's really interesting compared to what you have with other features. But still, a lot of things that you see in features, in Twitter features today, are coming from other applications. It's a bit of a pain to maintain those kind of tools, but with Finagle, you will see that you still have to keep your brain a little bit split, so to handle between the Scala world and the Finagle world, even through the written in Scala. So. One thing you can do with Future is that for those who do functional programming, they basically monad, so you can compose them. You can apply functions like map, flat map, handle, and rescue to handle exceptions. So a service is just a function that take a request and gives you back, instead of a response, but a future that holds a response. So it's waiting for a computation to be done, and then you get that response back. That's how you write the service. This is a simple way. This is a dummy service. So you just extend. This is Scala code. You just extend the service here. You have an apply method as well, and you wrap your result into a future. So it's non-blocking when you're calling it from a client point of view. So this is what it does. And they're protocol agnostic, and like I say, you can compose them fairly easily. So here I have one here. Oh, sorry, I jumped the shark here a little bit. My slides are a bit intertwined. So filters, I talked about services, but filters actually are just wrappers between inputs and outputs. So you can give in any protocol, wrap it, do your transformation, and give something back in return. And they're also protocol agnostic, so they can come from HTTP or Thrift or whatever else. And like futures, they're composable as well. So here, how it looks, this is an implementation of a filter. This is how a filter is implemented in Finagle. So, come on, yes, okay. So just watch the last one, type filter here. Basically, it's a request and a response. Take a request, wrap them into a service, and give you back a future that's holding a response. If you want to explode that one, you can see that a future is actually a set that has 4 types: an entering request that's rec in, a response out that's done after rec in is done, a request out, and gives you back a response in. So you work between 2 and does some transformation and gives you back. So the easier way to see them, this is how you can handle a filter. Like, say you want a timeout in your application, you want to call a service and you want a timeout. You just implement a timeout. This is one of the filters that are actually implemented into Finagle, but of course you can implement your own. And you write a service. This is the one we did here. I just create a new service. This is a dummy service. And my server is going to have a timeout filter and my service. And I'm composing the filter and the service with the and then keyword. So that's a way I can compose my services and all my filters to build servers. And to launch my server, I just launched a feature to wait for the server to, this is an HTTP server, so I just start this one and wait for the server until it's closed. This is how you launch a thing. So filters are really useful. For example, if you want to implement retries, you want to add a logging filter, you want to add a specific serialization, authentication. You have a lot of useful things that you can do with filters. Basically, it's a way to add things into Finagle. So clients, I'm not sure it's clear so good. Clients in Finagle are actually full stack services. They're actually some of the most important places because they come with a lot of features already. You have load balancing. They have their own way to handle session timeouts. You have a way to monitor and trace them. And they really come with services where you can plug in whatever you like, but they have some good defaults on top of which you can build. So Here, how you implement a client, basically it's just another service. You can serve it like as if it was another server, but the client is a server that comes with a lot of bundled in features. And to see how it looks like in the end is that you have clients that hit a filter, that filter transform the request, retransform it, call the server, does the transformation, and does the chain back in the end. That's a simple way to compose actually services with Finagle. Now, Finagle, like I said, is protocol agnostic, but of course it comes in with some pre-implemented protocols. One of the main protocols, of course, is HTTP, so that's an easy way for you to build HTTP services, but sometimes you don't want to use HTTP, like I said. When you're in an internal server, you want to use some really known RPC protocols, like those we have with Thrift, for example, which comes with its own RPC implementation, which can be plugged to actually protocol. Now, Thrift is natively actually supported by Finagle. So you just plug Thrift into Finagle. And it used to be that to build application within services within Finagle, you had to go through a different APIs. Hopefully this is changing. So you have this MySQL, for example, you want to build MySQL services. There's a way to actually import MySQL and call MySQL new service. That's the way they actually converging to a new API where you can actually have pre-implemented protocols called protocol, the name of protocol, for example, here, where I called HTTP, I just called the HTTPX new service, and there are ways coming actually to do that. So Finagle actually support all of these protocols: Thrift, Memcache protocol, Redis, HTTP, SMTP, MySQL, Zookeeper. The Finagle uses Zookeeper for a lot of things, so I'll come back to it. And another protocol, which is MUX. MUX is actually a way to do multiplexing of different protocols. For example, it's a bit hard sometimes when you have servers. We want at one endpoint to receive different calls. So different calls from different protocols. So for example, I have one endpoint here. I want to read data coming from a Facebook API in Thrift, from another Facebook API that's throwing at me JSON data, from another Google API, and doing them asynchronously and not blocking. And that's something that's a bit hard. So in order to do that, you need to go into, I don't know if you know the OSI layer, networking layer. That's the 7 layer. This is at the session layer, actually. So it's a protocol that sits there and that lets you actually handle multiple connection and multiplex multiple protocol into one single endpoint. And it has some really good things built in, like a way to manage head-of-line blocking, which can be a bit hard sometimes to manage, because that's things that really comes to that really are a problem in production services, and it helps you actually maximize the way you're using your bandwidth. So Finagle MUX is actually literally an interface on top of which you can build other protocols. So one of the main protocols today built on top of Finagle MUX is Thrift MUX. So you can multiplex using the Thrift server itself, different protocols on top of Finagle. That's a few things. And another one that I want to talk about is Finagle Serial. Serial is actually a short word for serialization. Basically, I don't know, when you behind a firewall or you're in a controlled environment, you're doing RPC, you don't want to do that with JSON. You want to use binary serialization format. So whether it's Avro, Protobuf, Thrift, I don't know, whatever you want. Finagle lets you actually plug your own serialization format. So you can have Avro, protocol buffer, and Finagle Serial is the library that lets you do that. For those who do Scala, there's something called S-codec that lets you actually do the same thing. And S-codec can be plugged into Finagle Serial as well, so you can multiplex over Scala-based serialization format. So yes, this is what I was talking about. Why you want to use binary format? Well, because if you use text-based format, you spend a lot of time actually just doing JSON serialization and deserialization. So if you can't avoid that, well, you'd better do. And one other thing in Finagle is service discovery. Finagle has a lot of projects. One of these is called Finagle Server Sets. So it's using Zookeeper instead to do service discovery. So basically, you register a service within Zookeeper, and you can actually look it up, look it up by using server sets, which acts as a naming service or something close to that, built on top of Zookeeper. But nothing is forbidding you to actually build service discovery on top of other platforms. So Finagle, like you've seen, there are a lot of things in Finagle. But Finagle, if you want to build servers within Finagle, it can be a little bit hard to wire all these services around. You want to have an admin interface. You want to have different things to actually build that. So Twitter came up with something called Twitter Server, which gives you a template of servers built on top of Finagle. So this is how Twitter builds the server. And it gives you flags for configuration, a way to do proper logging, and a way to monitor your metrics, and gives you an admin HTTP. So for example, one way you can see, okay, look. So this is, for example, this is a dummy, something I pull up from production service. I just removed a few stuff. So this is a Twitter server, which is built on Finagle. So I'm not seeing anything called Finagle on it. I'm using the MUX protocol, but for HTTP. I've added some handlers, so I can have multiple protocols here, but I'm just going to try one. And I have a service. This is a service that takes a string in JSON, does the transformation, and gives you back a serialized string. This is not efficient, but just for the sake of to see how it looks like. So I've implemented a service. This is the apply method. It does the work here, gives back a future value. Good. So let me start this. Oops. A bit too small. So here I'm gonna launch the server. Let's hope it works. Please go. Good. It's Scala, so it takes its time to work. It's not really in a rush. Good. So here I have started a Finagle, a Twitter server. You can see that a lot of admin endpoints showing up here. And I'm going to hit it with some requests, for example. But before I hit the request, I'm going to come here. Here I have an administrative interface that's built into Finagle. So I can see in production live behind, see what it looks like. So for example, you have a lot of metrics, JVM uptime, the number of thread counts, a real ton of metrics. So I'm not going to go into all of them. But just to see in live what it does, this is a way to do tracing. It's using a framework called Zipkin, but I have not plugged it. So just to see, I can monitor the GC load in real time, see what's going on in the heap, the size of heap that's being used right now in real time. Let's hit it with some request. Okay, so now I can see that it's changing. This is the size of a heap that's being used in real time. And in the meantime, I can look here. Well, I cannot see. Okay, this is the garbage collection. So you can do some GC dump and analyze them with another tool that's provided. It's called PCProf. And I can see how my server is behaving in live. So this is the load. It's showing you how your server is being loaded, how it's changing, the number of requests that are coming in. So you can see in real time how it's going. This comes really handy, especially when you want to deploy microservices and you want to tune your services in real time. So I have something like 10,000, 15,000 and see the number of requests actually coming in. If you're running things, for example, microservices independently in Docker, where I run services in Mesos most of the time, so I want to know exactly to troubleshoot what's going on into one service, I can hit one of these endpoints and see exactly how it's working. So I'll leave it at that and go back to the slides. Okay. Okay, that was Twitter server. That's what it gives you. And I've talked a lot about Finagle and Scala, but of course, you can do Finagle with Java as well. This is what it looks like. This is not Java 8, so it's not as fancy with lambdas and yes, but still. So this is a way you can build Finagle. This is the old API of Finagle actually, because they haven't changed the Java API yet. So if you want to be safe, just use the Scala one. It's a bit hard to wire all the Finagle APIs. Now, Finagle, of course, can be hard when you just want to build API services or HTTP REST APIs. You want to do something else, you want to do it very easily. You don't want to build RPC. Now, Finagle lets you build these kind of things too. So Twitter came up with this little framework, little library called Finatra. I don't know, anybody knows Sinatra here? Not the singer one, not the singer guy. I mean, the framework in Ruby that does, yes. So basically, it's inspired by Sinatra. So it lets you build HTTP services on top of Finagle. So it's a bit straightforward, but a little bit hard to maintain in production, but it does the job. So it has this idea of controllers and servers. So this is a simple API that lets you build a controller that says hi into get endpoint, an endpoint and the post, and let you post hi. This is exactly how you do it in Ruby if it was Ruby, but something close to that. You build controller. It's a bit easy. And you build the server by adding filters like in Finagle. So you register them with logging, tracing, and all the things you have. So it's not that hard. And there's another one called Finch, which sits between Finatra and Finagle, which is for those who really like functional programming. If you're into things like shapeless, generic programming, the way you handle your data in a very functional way, this is purely functional wrapper on top of Finagle HTTP. So it lets you build REST APIs just for HTTP. I didn't say, but Finatra is for HTTP, but also support Thrift, so you can do both. But Finch is for REST APIs, and it has performances that are really close to Finagle itself, so it's really fast. One other thing is Zipkin. Zipkin is a way to do distributed tracing. I think it was built by Twitter a long time ago, but now it has moved to something called OpenZipkin, so it's really open source. It's not controlled by Twitter as well, not much controlled by Twitter. So it's an implementation of the Google paper called Dapper, so it's a way to trace where your system is slowing. So this is what it looks like. So basically you have multiple services over there, and from each services, it gets a sample of all your log and all your requests and lets you see exactly where your service is taking too long to complete. So you can trace all of your systems. So it's a nice tool to have, and it's built in within Twitter server. You just have to launch a Docker container and actually see how it does the job. So you can plug it as well into the admin interface of Twitter server. It's a nice tool to have. But Finagle is not perfect, of course. It has some really not so appealing properties. So for example, because it's stuck to old versions of native. This is due to how Twitter is slow to move to new versions, the big house. So since they're the primary developers of Finagle. So currently Finagle is stuck to native 3, but it's moving to native 4. But native already have native 5 in beta. But hopefully, what's nice is that the native developers actually contribute back or backport most of the work that's done on native 5 into native 3, for example, security features. And one of the main developers of native works at Twitter on the Finagle team too. So when something happens, exactly, he knows how to fix that. In the last versions, since the number 6. That X versions, so you have some changes of API, so it's moving into you don't have the native API leaking into Finagle, so that's really nice. So it's slow to update, and documentation is not so nice. So hopefully the mailing list is quite vibrant, and Gitorim on GitHub, so people are very responsive, and you're seeing a lot of things actually being built around Finagle, like many projects. So sometimes it's a bit hard to find its way around it. But yes, it's moving quite well right now. Really good. So that was the demo I wanted to show. So if you want to build RPC, you want to try something different. If you're doing Scala, Akka is great. I love Akka. If you love Play or love Spread, that's nice. But try Finagle as well. It brings in, if you want to really go into raw performance, it's really nice. That's all I had. Thank you.